Hello students and welcome to the lesson on solving inequalities, and we're going to start here by solving absolute value inequalities. So I have an inequality here that says the absolute value of x is less than 4. And so it helps when we deal with absolute value to think about what that means. So if you recall from earlier classes that absolute value means distance from 0. So what this statement is saying, and I'll write this in words here, is that x, whatever it is any number whose distance from 0 is less than 4. So it's any number where the distance from 0 is less than 4. So let's take a look at this on the number line. So 0 is on the number line because absolute value is defined in terms of 0. And we want a number whose distance from 0 is less than 4. So let's try a few. Okay, so let's try and guess. Well, does 3 work? Well, let's say I'll mark here 1, 2, 3. So 3, absolutely that works. Okay, the distance from 0 to 3 is definitely less than 4. How about 2? That also works. And 1 also works. That distance is less than 4. We can also look at the negative values, -1, -2, -3. Okay, so that also works as well. And so basically there are an infinite number of solutions. Okay? And we want to be able to express all of those solutions in a concise and complete statement. So we can mark x as some point here on the number line, and the distance from 0 to this point has to be 4 or less. So it can be any point along this segment here. And if we go to -4, it can also be any point here from -4 to 0, because the distance between any of these points in the segment to 0 is less than 4. Okay? Now since it's less than, we use the open circle to indicate that it is not including the boundary points. So the answer to this solution is that x can be anything between 4 and anything -4. Okay, so x can be between any of those two numbers. Okay, and if you think about this in terms of the number line, it'll help to make sense a little bit, because again, absolute value just means the distance from 0. And this statement says that the distance from x to 0 is less than 4. Now let's try another example. This time, instead of less than, we will work with greater than. So if you recall from the previous example, we looked at a case where the absolute value of a variable is less than a number. And let's look at a case where it's greater than. So in words, this basically says x is any number whose distance from 0 is greater than or equal to 6. Okay. And so let's see what that means exactly when we look at this on a number line. So here's our number line. Here is 0. And let's put 6 right here, and let's put 6 right here. Okay. -6, I should say. Now, anything that is satisfying this condition has to be farther away from 0 than 6. Okay? In other words, it has to be 6 units or more farther away from 0. So we have to start here. Okay? And basically, any number that's between 0 and 6 does not work. The only numbers that work would be anything bigger than 6. So we can try, right? We can try 5. Does that work? Well, 5 is right here, and the distance between 0 and 5 is 5, which is not greater than 6, so that doesn't work. We can try 6, Does that work? Well, 6 is right here, the distance. Absolutely, that works. We can try 7. That's way out here. Does this work? Well, the distance between 0 and 7 is 7. So that works. And in fact, it works for all of the values that are starting from 6 and that's going towards the right. Now keep in mind, we also have to take care of the left side here. All of the numbers starting from -6 to the left have a distance from 0 greater than 6. Okay, so we can express this as an inequality like this way. X is less than or equal to -6, or x is greater than or equal to +6. And this entire statement is the full and complete answer. Now, just to review and to practice a little bit, let's use interval notation. X is less than or equal to -6 means that x can be anything between -infinity, because we're heading towards the left here, and -6 inclusive. We use the bracket. Union with anything from 6, +6, onwards to +infinity. And remember, the parentheses means that it's exclusive, it does not include the boundary, and anything with infinity or -infinity is always exclusive because you can never actually touch infinity. And let's write this one here too in interval notation. X is between -4 and +4, so the lower bound is -4, the upper bound is +4. So this is in interval notation. There you have it, a couple of examples on dealing with absolute value inequalities. Bearing in mind what these values really mean, these expressions really mean, notice that when the variable is the absolute value is less than something, then whatever expression is in the absolute value symbol is in between the two boundaries, the two possible points. When it's greater than, then it's to the right and to the left. So keep that in mind, okay? Less than, if the absolute value is less than a number, then it is in between the positive and negative. Just like here, if it's less than 4, it's between -4 and +4. If the absolute value is greater than a number, then it is to the right of that number and to the left of the negative number. Okay, so you should hit pause here, digest it a little bit, and then we're going to go on and ask yourself if this really does make sense. Try a few other examples before we go on to something slightly a little bit more difficult. Okay, so I've got an example here that's actually two related problems. One is that the absolute value of x minus 3 is less than 5, and the other problem is the absolute value of x minus 3 is greater than or equal to 5. And before we go further, you should try this problem on your own. Hit pause, try to work on it, and then hit play again and see how I solve this problem. So to solve this one, remember from the last example, examples 2 and 3 actually, 1 and 2, that if the absolute value expression is less than a number, that means that on the number line, so again, this is, actually let me draw my number line on the side here. Okay. So this is saying that the distance from x minus 3 to 0 is less than 5. So if this is your number line, if this is 0, well, x minus 3 is some value here. We don't really know what this is. And all we really know is that the distance from here to x minus 3 is no more than 5. Okay, well, so whatever this number is right here, the distance from that number to 0 has got to be 5 or less. Same thing on the other side. So from here to here, it's got to be 5 or less. So one of the things that we can do is we have to split this into two equations, and we have x minus 3. Oops, let me write it this way. So we have x minus 3 has to be greater than negative 5, and x minus 3 has to be less than positive 5. Okay? In other words, x minus 3 has to be between this distance here has to be 5, and this distance here also has to be 5. Okay? So if you're not sure how this works, just look at back and compare examples 2 and 1 with this one. In the other examples, I think we had this problem. And all we're doing now is, and then we solved it by saying that x is less than 4 and x is greater than negative 4. I think that was the solution that we used last time. Okay? And all we're really doing right now is replacing x with x minus 3. So it's a slightly more complicated problem. So we can solve for x here, and we can say that we can add 3 to both sides, and we know that then x is greater than negative 2. And then we can also add 3 to both sides in this case, and we know that x has to be less than 8. So our final solution is that negative 2 is less than x, which is less than 8. In other words, x is between negative 2 and 8, which, let's draw the final number line here. That's 8 here, that's 0 here, that's negative 2 here. Okay? And x can be any number within this range. And let's practice writing this in interval notation. So this says that x is between negative 2, that's the lower bound, and positive 8, that's the upper bound. And that is our final answer. And actually, both of these are good answers. It just depends on what format that we're asked to solve for. Okay. Now moving on to part B, and again, you should hit pause, compare this to example 2, and see if you can do it by yourself, and then hit play. In doing so, it will really help you to test yourself and to train your mind to truly understand these concepts. So if you remember, recall example 2, where we had x is greater than or equal to, I don't remember, I think it was 5 or 6. So it was 5 back then. Okay. And what we did there was we said that x has to be greater than or equal to 5, and x has to be less than or equal to negative 5. So we're doing the same thing here, but the only thing that's a little bit different is we're replacing x with x minus 3. And so we need to solve, oops, this right here should not have an absolute value symbol. And so we need to solve two inequalities. The first one is going to be x minus 3 has to be greater than or equal to 5. And the other one is x minus 3 has to be less than or equal to negative 5. Add 3 to both sides, and you get x is greater than or equal to 8. Add 3 to both sides, and x is less than or equal to negative 2. Okay, and this is an OR statement. It's very important we use the word OR here. And when it's something like this, we cannot combine them together, because if we do, the entire statement would not make sense. But let's show this on a number line. So here's 0, here's 8, and here's negative 2. And this is basically saying that it has to be farther away than 8 and farther away in this direction than negative 2. It has to be less than or equal to negative 2 and greater than or equal to positive 8. And so this is actually one possible answer. This is the graph. And in interval notation, we would write this as from negative infinity to negative 2 union with, oops, this should be a bracket, from positive 8 to positive infinity. Okay. And these are three expressions of the same statement. And when we put more complicated expressions in here, it's gonna seem a little bit weird, but if you just think back to the original problems of example 1 and 2 and what that means, and all we're really doing is replacing the basic expression with something a little bit more complicated, and the way in which that we solve them is pretty much the same.